tangent to a circle. Now, a straight line drawn outside a circle and which touches the circle at exactly one point is the tangent to that circle. So a tangent is a line drawn to touch one point of the circumference outside the circle. So a tangent is indicated with the line here. Now, the point where the tangent and the circle meet, or the tangent touch the circle, we call it the point of contact. So in this diagram, our point of contact is point P. From the center, when we draw a radius to the point of contact, the radius will be perpendicular to the tangent line, as you see here. So the radius with red vertical line is perpendicular to the tangent line, which is horizontally drawn. And so once the radius is perpendicular to the tangent line, it means that the gradient of the radius will be the negative inverse of the gradient of the tangent line, as we already know of two perpendicular lines. Example 1. Find the equation of the tangent which touches the circle x squared plus y squared plus 4x minus 10y equal to 12 at the point 3, 1. So our point of contact is 3, 1. And we have to find the equation of the tangent line. So our solution, now for us to find the equation of the tangent line, we need the gradient of the tangent line and then a point that the line passes through. So the tangent line passes through the point of contact, which is 3, 1, but we are yet to determine the gradient. Okay, so how do we find the gradient? First of all, let's determine the center of the circle. So our circle, when we compare with the general formula, x squared plus y squared plus 2gx plus 2fy plus c equals 0, we find that our 2j is equal to 4. Our j will become 2, and that means that the center A is equal to negative 2. Then our 2f is also equal to minus 10. Our f will be minus 5. And that means that our b will be equal to positive 5. So the center of the circle is negative 2, positive 5. Now, from the center to the point of contact, that is the radius. So let's find the gradient of the radius. So gradient of radius will be 5 minus 1 divided by negative 2 minus 3. This will give me 4 divided by negative 5. So that will be my gradient. Now, if a line is perpendicular to the radius, then its gradient will be positive 5 over 4. That is the negative inverse of the perpendicular line. So the gradient of the tangent line is positive 5 over 4. Now, with the gradient known and then a point 3, 1 also known, we can determine the equation of the tangent as y minus 1 is equal to 5 over 4 multiplying x minus 3. So 4y minus 4 is equal to 5x minus 15. So our tangent line will be 4y minus 5x plus 11 is equal to 0. That will be our tangent line. Example 2. Find the equation of the tangent which touches the circle x squared plus y squared minus 2x minus 2y minus 59 is equal to 0 at the point 6, 7. Okay, so let's solve. The center of the circle, we have 2g. When we compare with the general formula, 2g is equal to negative 2. J will then be negative 1. And so our A will be equal to 1. 2f is equal to negative 2. F is equal to negative 1. And that our B will also be equal to 1. Which means the center is 1, 1. Okay. Now we can find the gradient of the radius which touches the point of contact. And the gradient m here will be 7 minus 1 divided by 6 minus 1, which will be 6 over 5. Now, a line perpendicular to this radius will have a gradient minus 5 over 6. That is the negative reciprocal of the gradient of the line, which is perpendicular to it. So now we have the point of contact, which is a point the tangent pass through, and the gradient of the tangent. So we can determine the equation of the tangent as y minus 7 is equal to negative 5 over 6 multiplying x minus 6. So here I have 6y minus 42 is equal to minus 5x plus 30. So 6y plus 5x will be equal to negative 70, no, positive 72. So that will be the equation of the tangent line at 6, 7. Normal to a circle. Now, a normal is a perpendicular line to the tangent of a circle. And the normal is drawn to meet the tangent line at the point of contact. And so it is collinear. And the normal is collinear with the radius, which also touch the point of contact. As you can see from the diagram, the normal is the blue line here, and it is perpendicular to the tangent which is touching the circle. And when you look at the normal, it is in line with the radius which also touch the point of contact. And so if we have a radius which touch the point of contact, it will have the same gradient as the normal. I hope this is clear. Find the equation of the normal to the circle x squared plus y squared plus 16x minus 10y minus 28 is equal to 0 at the points -2, -4. So as we said earlier, the normal to a circle has the same gradient as the radius which touch or which is drawn to the point of contact. So let's determine the center of a circle. Now when we compare the given circle to the general formula, we will have 2g to be equal to 16. That means g is equal to 8 and our a will be equal to -8. Then 2f is equal to -10. So f is equal to -5 and b is equal to +5. Therefore, the center of the circle is -8, +5. Now, we can find the gradient of the radius which touch the point of contact, and that will be given as, let's say, m is equal to 5 minus -4, which will be 5 plus 4, divided by -8 minus -2, which will be plus 2. That will be 9 over -6. When we simplify, 3 goes into 9 3 times and goes into -6 2 times. So the gradient will be -3 over 2. And we said that the gradient of the normal is equal to the gradient of the radius, and so the gradient of the normal will also be -3 over 2, and the normal also passes through the points -2, -4. So the equation will be given as y minus -4, which is 5 plus 4, is equal to -3 over 2 multiplying x plus 2. So we have it as 2y plus 8 is equal to -3x minus 6. 2y plus 3x plus 14 is equal to 0. That is the equation of the normal as required. Example 2. A circle is defined by x squared plus y squared plus 2gx plus 2fy minus 15 equals 0. The gradient of the tangent to the circle at the points 3, 2 is -1 over 2. Find the value of g and f. So our solution, looking at the question, we can say that the gradient of the radius which touch the point of contact will be given as +2. That is negative inverse of the gradient of the tangent line. With that, we can determine the center. So from the equation given, our -2a is equal to 2g. That means our a is equal to -g. And then -2b is also equal to 2f. which means our B is equal to negative F. This means that the center of the circle is negative J, negative F. And the gradient of the radius which touch the point of contact will be given as 2 minus negative F, which is going to be plus F, divided by 3 plus J, will be equal to 2, as we have already determined. So we are going to have 2 plus F is equal to 6 plus 2J. When we simplify this, we will get 2J minus F is equal to negative 4. And that will be our equation 1. Then we also know that any point that is on the circle satisfies the equation of the circle. And so we are going to substitute the point of contact into the equation, and that we are going to get 3 squared to be 9 plus 2 squared to be 4 plus 2 times 3 times j, which will give us 6j, plus 2 times 2 times f, which will also give us 4f, minus 15 is equal to 0. Now when we simplify, we get 6j plus 4f minus 2 is equal to 0. If I divide through by 2, I get 3j plus 2f is equal to positive 1. That will give me equation 2. Now I want to multiply equation 1 by 2, and then I'm going to add the result to equation 2. So when I multiply by 2, I'm going to get 4j minus 2f is equal to minus 8. Now adding this to 3j will be 7g, and then 2f minus 2f will go away. 1 minus 8 will be equal to minus 7. And so from here, when I divide through by 7, j will be equal to negative 1. And then if I substitute j into equation 1, I have 2 times negative 1 minus f is equal to negative 4. So I'll get minus 2 plus 4 is equal to f. And that means f is equal to positive 2. And that is the answer. The example 3. The equation of the tangent to a circle at P 4, 2 is 3y is equal to x plus 2. The line y is equal to 3x passes through the center C of the circle. Given this information, find the coordinate C, that is the center, the equation of the circle, and thirdly, the points T1 and T2 where the circle cuts the y-axis. Okay, so from the equation 3y is equal to x plus 2, we can find our gradients as y is equal to 1/3 x plus 2 over 3. So the gradient of the tangent is given as 1 over 3. That means the gradient of the normal to the tangent at the point of contact P will be given as -3. That's the gradient of the normal. So let me put small t on the tangent gradient and then put small n on the normal gradient as this. Now with this given, I can find the equation of the normal because I know that it passes through the point P. So the equation of the normal will be given as y minus 2 is equal to -3x minus 4. So y minus 2 is equal to -3x plus 4. And so my equation will be y plus 3x is equal to 14. This is the equation of the normal to the circle. And so I can rewrite it as y is equal to minus 3x plus 14, and then that will be my equation 1. Now let's remember that the normal passes through the point of contact to the center, and that we have the line being a line that passes through the center. And then we have also been given another line that also passes through the center as y is equal to 3x, which means that these two lines intersect at the center. And so when we find their point of intersection, we will get the coordinates of the center of the circle. So let's solve simultaneously. So I'm going to add the two equations, and that's so equation 1 plus equation 2. I'll get 2y is equal to, now negative 3x plus 3x will cancel out. So 2y will be equal to 14. That means y is equal to 7. Then if y is equal to 7, then 7, if I substitute into equation 2, 7 is equal to 3x. And that my x will also be equal to 7 over 3. Therefore, the center of the circle is given as 7 over 3 and 7. That is the center of the circle. Now we have the center as 7 over 3 and 7. So I'm going to substitute it into the general formula of the equation. So s squared plus y squared plus 2. And j is negative a. So we have negative 7 over 3x plus 2. And then f is also negative b. So negative 7y plus c is equal to 0. So I'll open the brackets, s squared plus y squared minus 14 over 3x minus 14y plus c is equal to 0. Now I also have the point P, which is 4, 2. And this point, because it is on the circle, it satisfies the equation. So I'll substitute into the equation. So 4 squared will be 16 plus 2 squared will be 4. Then I'll have minus 14 over 3 times 4 minus 14 times 2 plus c is equal to 0. And this 16 plus 4 will be 20 minus 14 times 4 will be 56 over 3. 14 times 2 will be 28 plus c is equal to 0. Now 20 and 28 will become negative 8. So minus 56 over 3 minus 8 plus c is equal to 0. Now when I add the 2, I will get negative 80. Negative 80 over 3 plus c equals 0. And that means c is equal to 80 over 3. Now I will substitute to get my general formula as s squared plus y squared minus 14 over 3x minus 14y plus 80 over 3 is equal to 0. So now I want to multiply through by 3, and that will give me 3s squared plus 3y squared minus 14x minus 42y plus 80 is equal to 0. So that becomes the general equation as required by the question. Now the question continues to say that there are 2 points T1 and T2 where a circle intersects the y-axis. And so that means that we are looking for the y-intercept. It occurs when x is equal to 0. Okay, so when we put s to 0, we have the equation as 3y squared minus 42y plus 80 is equal to 0. Okay, so we have 3y squared minus 42y plus 80 is equal to 0. So we are going to solve for the root of this quadratic equation. Okay, so when we do that, we are going to obtain y to be equal to 11.73, and also y is equal to 2.27. I'll leave that calculation for you to do. And so because it's a coordinate, it's a point that we are looking for, we remember y(s) is 0. So the point T1 we shall say will be the point 0, 11.73. And then T2 we will say 0, 2.27. And that is the solution to the question. Length of tangents from a point. So from the point Q, so we are looking at the length of the tangent from this point Q to the point P. That is how long the tangent will come from the point Q to meet the point P. Okay, so in doing this, we look at the shape of the triangle that has been formed here. So we join a straight line from the point given to the center of the circle. and then from the center of the circle to the point of contact, and then the tangent itself, it gives us a right angle triangle. That means if we are able to determine the length of the radius, and then if we are able to determine the center, we can also find the length of the point Q to the point C. And once we get QC and then CP, by Pythagoras theorem, we can determine PQ. I hope this is understandable. Okay, so we'll go ahead and solve an example. Okay, so I will take our first example. Find the length of the tangent from point A, which is negative 3, 2, to the circle x squared plus y squared is equal to 3 plus 2x minus 3y. So let's solve. Now we have our circle. We rearrange x squared plus y squared, then minus 2x plus 2y minus 3 equals 0. Okay, so with this we see, comparing with the general formula, we have our 2g to be equal to negative 2. So our g is negative 1, which means our a is equal to 1. Then our 2f is equal to 2. So our f is equal to 1 and our b will be equal to negative 1. That means the center of the circle will be 1, negative 1. Okay, now we have the center. So from the point A to the center, the length we get will be, so let's label the center as O. And so we are looking for the length OA. And that will be OA squared, so square root of minus 3 minus 1 squared plus 2 minus minus 1, so plus 1, also squared. And that will give us 4 squared, which is 16, plus 3 squared, which is 9. And that will give us root 25, which eventually gives us the length to be 5 units. Now we know the length there, so we also try to find the radius. So looking at the equation, our c is equal to negative 3. Then our g is equal to negative 1, and our f is equal to 1. With these values, we will be able to find our r squared, which will be given us. Okay, so r directly, r will be square root of g squared plus f squared minus c. And that we have minus 1 squared plus 1 squared minus negative 3. So we have root of 1 plus 1 plus 3. That is root of 5. And so this is our r. We can say our r squared will be equal to 5. Okay, now for the length of the tangent, we will have the longest side, which will be OA. So the length OA squared plus is going to be OA squared will be equal to the radius squared plus the other, let's call it the point of contact, let's call it P. So we can say AP squared. Okay, so our OA is 5 units, so 5 squared. Then our R squared is 5 plus AP squared. And so our AP squared here will be equal to 25. So 25 minus 5. Our AP will be equal to root of 20, which we can write as 2 root 5. So that is the length of the tangent from A to the circle given. Determining whether or not a line is a tangent to a circle. Okay, now when we are given a circle and then there is a line that is possibly a tangent to that circle, we remember that from the center to the point of contact of the tangent, the distance is the same as the radius. And so when we have to check whether a line is a tangent to a circle, we will have to check whether the distance between the line and the center of the circle is equal to the radius of the circle. And that is how we do it. And so when you look at it from the radius to the tangent, we get perpendicular distance to a line. And that, if we remember, our formula is ax plus by plus c divided by the square root of a squared plus b squared. And these are in absolute values because it is a distance. We can't have a negative value. So this is how we find it, where as plus plus by plus c equal to 0 is the equation of the line, and x and y will be the points given, the point that is perpendicular to the line that we seek. Okay. Example: determine whether the lines 5y equal to 12x minus 33 and 3x plus 4y equal to 9 are tangents to the circle given. Okay, so this is how I will do it. My circle is this. I'm rewriting this way. Now my 2j is equal to 2, my j is equal to 1, and my a is equal to minus 1. My 2f is equal to minus 8, my f is minus 4, and my b is equal to 4. Therefore, the center of the circle is negative 1, 4. Now, I would want to now find the length of the radius. So what will be the length of the radius of the circle? Now, radius squared is given as j squared plus f squared minus c. Thus, the radius is equal to square root of j squared here will be 1 squared plus f squared is minus 4 squared minus c. So minus -8. So my r will be square root of 1 plus 4 is 16 plus 8, that will give me root of 25, and so my r is equal to 5 units. Okay, so with the radius found, I'm going to compare the length between the line and the center. So I take the first line 5y, so I will rewrite the line as 12x minus 5y minus 33 is equal to 0. Okay, so I'm putting that into the formula. That is ax plus bx, ax plus by plus c in absolute value divided by root of a squared plus b squared. When I substitute that, I'm getting 12 times -1 minus 5 times 4 minus 33 in absolute values divided by the root of 12 squared plus -5 squared. So I'll get -12 minus 20 minus 33 divided by root of 144 plus 25. That I'll get -65 over square root of 169 in absolute values, and that will give me -65 over 13. Because they are in absolute values, my result is 5 units. Now comparing the length obtained and the length of the radius, we can see the line 5y is equal to 12x minus 33 is a tangent. So it's a tangent. True. Now we go ahead and test for the second line. We remember our r is 5 units. Okay, so for the second line, we are also going to have the equation as 3x plus 4y minus 9 equals 0. And when I substitute, I'm getting 3 into brackets -1 plus 4 into brackets 4 minus 9. And I'm dividing this by root of 3 squared plus 4 squared. So I have -3 plus 16 minus 9 divided by 339, 4, 4, 16, root of 25. Okay, so -3 plus 16 will be 13 minus 9 will be 4. So 4 over root 25, that will be 4 over 5. And this will give a value that is less than 5. So that's it will be 0 point something, and that means it will not be equal to 5. Therefore, the second line is not a tangent. So that is how we test for tangent line. Another example, determine whether the line 3x minus 4y plus 14 equals 0 is a tangent to the circle x squared plus y squared plus 4x plus 6y minus 3 is equal to 0. So as usual, we need to determine the radius and the center. So if we compare, we see our 2j to be equal to 4. So j is 2 and a is minus 2. Then 2f is equal to 6. So f is 3 and b will be equal to minus 3. That means the center of the circle will be negative 2, negative 3. With that, I can find my radius. J squared here is going to be 2 squared, and f squared is going to be 3 squared minus c, which is negative 3. And that means I'll get 4 plus 9 plus 3. And that is root of 16, which is equal to 4 units. Now with my radius, the length of radius obtained, I'm now going to compare with the length of the line. So as usual, ax plus by plus c divided by square root of a squared plus b squared, and that will give me 3 times negative 2 minus 4 times negative 3 plus 14 divided by square root of 3 squared plus minus 4 squared, and that's 3 2 is minus 6, 3 4 is positive 12 plus 14 divided by 3 3 9 4 4 16, which is root of 25. So negative 6 plus 12 will be positive 6, and plus 14 will be positive 20 over root 25 is 5, and that will give me 4 units. Now looking at the length and the length of the radius, we can conclude that the line 3x minus 4y plus 14 equals 0 is a tangent to the circle.